Hello guys, I welcome you all for the today's video, and today's video is about the NoSQL concept, that is peer-to-peer replication. And before getting into topic, let me introduce myself. I am Lakshmi Vaibhavi, currently pursuing B in CSC AI at SVC. So what are all topics or what are all the the concepts we'll be looking into this topic is one is will be exploring the benefits of peer-to-peer applications, then architecture, then advantages, challenges, and potential futures directions of this technology. Before As we all know, NoSQL databases is a simple relational databases which stores our data in a non-tabular format. So it's of easy to use, then it also provides the flexibility, then scalability, and also it is highly available. This supports not only it's not only targeted for one data models. It supports the various data models like graph data models, key value, and the documents. So where and all we use this NoSQL are in social media platforms where MongoDB is used for the data storage, then e-commerce, then real-time data analytics. So these are the basic, basics of this NoSQL databases. Next, what is need? Why we need the replication concept in NoSQL? One, it provides fault tolerance. How? By ensuring the data availability even though one or node fails. Sorry, node fails, because it's not only targeted for one nodes. We can assure our data, or we can regain back our data from other nodes also. So redundancy prevents the data losses. Next is high availability, provides continuous access to the data by distributing the copies across the multiple nodes. Then is scalability, distributes workload and storage to handle the increasing data volumes and users request. So this is the why we need a replication concept in NoSQL. Next, coming into the what is this actual peer-to-peer architecture. So as the name itself suggests, peer-to-peer. Here, no nodes acts as a this slave. Here, there is no slave or the master concept in this. Here, all the nodes will act as a master itself. Here, all the nodes are masters. So this occurs between the tables, in the tables on two or more servers. So application on these servers can update same rows and columns in those tables at the same time. Then all the servers or the all the nodes are equal peers with equal ownership of the data. No server is the master, or no server is the the slave here. Then not only that, the main thing is it is decentralized. There is no centralization concept here. Nodes operates independently without central authority. Data is replicated across all participating nodes. Next, direct communication. No nodes act as an intermediator or the mediator nodes here. Nodes communicates directly with each other, forming a mesh network for data exchange and peer-to-peer communication. Next is data synchronization. Nodes maintain consistency through continuous data exchange and conflict resolution mechanism. So this is the peer-to-peer architecture. Here you can see the data has been transformed directly, or direct communication. So you can see here. So this cross arrow marks suggest the replicated data. Next, coming into the advantages of peer-to-peer application, as we have discussed, this is high availability. Data remains access even though nodes failures or redundant copies exist on the nodes. Next is scalability, easily add new nodes to the network, increasing the capacity and performance. You can replicate the data or the copies of the tables between the multiple servers in peer-to-peer replication at the same time. So this collection of all the copies of a single table is called as a logical table. Then each server has a copy of each server will be having a copy of those table. So the different versions of the table can have a different names and schemas. So in peer-to-peer replication, data convergence is assured between all copies of the logical tables, that meaning that each copy of the table eventually achieves the same state as the other copies and has the most the recent committed values, because peer-to-peer replication is an asynchronous and the copies of the tables might not converge until your application stops making changes to all the tables, and all changes are replicated once and messages are processed. So this is the process of the peer-to-peer replication. But and also it supports the reduced latencies because data is accessed locally from the nearest node, leading to the faster response time. Next, the challenges in peer-to-peer replication. Consistency. Ensuring the data consistency across the nodes can be complex due to potential conflicts. Next is how is conflict resolution. Developing a mechanism to resolve inconsistencies that arise from the concurrent updates is crucial. Next is network management, as it's a direct communication and most servers will be acting in this process. So managing a large number of interconnected nodes can be challenging and requiring efficient network protocols. And moreover, in this type of replication, you cannot manipulate the data by having the queue apply program pass the data to a store procedure. So there is at least one queue capture program and one queue apply program running on each server. So that is a part of the peer to peer configuration. Next is consistencies, models for peer-to-peer application, strong consistencies. We need all the nodes see the same data at same time, require synchronous approach. Next is eventual consistencies. Data eventually converges, suitable for applications that tolerate some delay. Next is casual consistencies, guarantees that casually related operations are executed in the correct order. A balance between strong and eventual consistencies. And in peer to peer configuration, conflict detection and resolution are managed automatically by the queue apply program in a way that assures data convergence. So you don't need to configure anything for the conflict detection or the resolution. Next is gossip based replication protocols. Random communication nodes randomly select the other nodes to exchange the data updates. Efficient scalability. Gossip protocols work well in large decentralized networks. Next is fault tolerance. Resilient to node failures as data is disseminated through multiple paths. Handling failures and partitions, detection, monitoring the node activity and identifying the network partitions. So this can be done using the heartbeat messages. Next is isolating the affected nodes from the network to prevent the data consistencies. Recovery, reintegrating the nodes once the network is restored and ensuring the data consistencies. So these are the the failures or handling the failures by partitioning. Next is conclusion and the future of directions. Peer-to-peer replication offers significant benefits for NoSQL databases, including scalability, high availability, then fault tolerance. As the field progresses, ongoing research will focus on optimizing the consistency models, improving fault tolerance mechanism, and exploring the new approaches to handle the network dynamics. So this is the conclusions of the peer-to-peer replication in NoSQL. So, and that's all, guys. Thank you.